Last session was about matrices. We learnt about basics of matrices and its operations, addition, subtraction and multiplication. आज के सेशन में हम inverse of matrices पढ़ेंगे. Inverse of a matrix. Consider a scalar k. मतलब, a constant या single element. The inverse is the reciprocal or division of 1 by the scalar. Example, k is equal to 7, the inverse of k or k inverse is equal to 1 by k, that is 1/7. Division of matrices is not defined. Matrix का division नहीं कर सकते क्योंकि जहाँ AB is equal to AC है, वहाँ ज़रूरी नहीं है कि B is equal to C, B may not be equal to C. इसलिए instead matrix inversion करते हैं. अगर A एक matrix है, इसका inverse matrix will be A inverse. A multiplied by A inverse is equal to A inverse multiplied by A is equal to I. I is unit matrix या identity matrix है. In this example, this is matrix A, of order 2 by 2, that is 3, 1, 2, 1, इसका inverse, यानी A inverse will be 1, minus 1, minus 2, 3. क्योंकि A multiplied by A inverse is unit या identity matrix. In last session, we saw, identity matrix के principal diagonal में number 1 होता है, और बाकी सब elements 0 होते हैं. When we multiply A inverse with A, that is 1 by 3, plus, minus 1 by 2 is 1, 1 by 1, plus, minus 1 by 1 is 0, minus 2 by 3, plus, 3 by 2 is 0, minus 2 by 1, plus, 3 by 1 is 1, the matrix obtained is 1, 0, 0, 1, which is an identity matrix. Similarly, when we multiply A with A inverse, we get identity matrix. Properties of the inverse. AB inverse is equal to B inverse multiplied by A inverse. A inverse whole inverse is A. A transpose inverse is A inverse transpose. Ka whole inverse is 1 by K into A inverse. Note: a square matrix that has an inverse is called a non-singular matrix. A matrix that does not have an inverse is called a singular matrix. Square matrices have inverses except when the determinant is 0. When the determinant of a matrix is 0, the matrix is singular. So, now let's understand what determinant is of a matrix. The determinant of a matrix is a single numerical value which is used when calculating the inverse or when solving systems of linear equations. The determinant of a matrix A is denoted det A or this A in between two vertical lines. Every matrix has a determinant and is unique. Determinant of a matrix is a unique number that can be calculated. Here, if A is a matrix, then its determinant is elements are written between two bars. Important thing that we need to know about determinant is it can calculate only square matrices, that is matrices of order 1 by 1, 2 by 2, n by n. How to find the determinant in matrix? If A is the matrix of order 1 by 1, it has only one element, that is number of rows is 1 and number of column is 1. Determinant A in between two vertical lines is equal to det A is equal to A1-1. Let's take an example. Matrix A, 8, determinant A is equal to 8 in between two vertical line is equal to 8 is determinant. Matrix A, -1, determinant A is equal to -1 in between two vertical lines is equal to -1 is determinant. If A is nxn, its determinant may be defined in terms of order n1 or less. Before understanding how to calculate determinant of 2 by 2 matrix or 3 by 3 or n by n matrices, let's understand two important terms, minors and cofactors. Minors. If A n by n matrix है और इस matrix से एक रो और एक column delete करें, then the resulting matrix is n-1 by n-1 जो मैट्रिक्स A का सबमैट्रिक्स है। सबमैट्रिक्स के डिटरमिनेंट को माइनर ऑफ A कहते हैं and is denoted by Mij, where I and J correspond to the deleted row and column, respectively. Mij is the minor of the element Aij in A matrix. Example, यहाँ ये 3 by 3 matrix है। मैट्रिक्स A के हर एक एलिमेंट्स का एक माइनर होता है। यहाँ फर्स्ट रो और फर्स्ट कॉलम को डिलीट करने से remaining to by to submatrix is minor of A11 element. That is M11 is this submatrix. Similarly, minor of A12 is M12, which is this, that is first row and second column is deleted and we get this determinant. Similarly, minor of A13 is M13, which is this, that is first row and third column is deleted and we get this determinant. Cofactors. The cofactor Cij of an element Aij is defined as Cij is equal to -1 to the power I plus j into Mij, when the sum of a row number I and column j is even. Cij is equal to Mij, and when I plus j is odd, Cij is equal to minus Mij. Now here, in C11, I is 1 and j is also 1, so 2 plus j is 2, which is even number, hence plus M11. In this C12, I is 1 and j is 2, so I plus j is 3, which is odd, hence minus M12. Similarly, C13, I is 1 and j is 3, so I plus j is 4, which is even number, hence plus M14. Now, let's see how to calculate determinant of n by n matrix. Determinant A is defined as A is equal to A11 C11 plus A12 C12 plus so on till A1 n C1n. The determinant of A is therefore the sum of the products of the elements of the first row of A and their corresponding cofactors. It is possible to define determinant of A in terms of any other row or column, but for simplicity, the first row only is used. Example. In this 2 by 2 matrix, cofactor C11 is equal to plus M11, as here I plus j, that is 2, which is even, hence plus M11. It is equal to determinant A to 2, that is A to 2. That is to get M11, minor 1 1, remove first row and first column, after removing it, we get A to 2. Similarly, cofactor C12 is equal to minus M12, as 1 plus 2 equals 3 is odd, hence minus M11. It is equal to determinant minus A to 1, that is minus A to 1. To get minor 1 2, remove first row and second column, after removing it, we get A to 1. And the determinant of A is, substituting the values in equation, determinant A is equal to A11 C11 plus A12 C12. We get determinant A is equal to A11 A to 2 minus A12 A to 1. We get minus A1 to A to 1, as C12 is minus A to 1. That is determinant A's product of these two, minus product of these two. Example, in this 2 by 2 matrix, determinant A is product of a 1 1 and A to 2 minus product of A 1 2 and A 21. Product of these two, minus product of these two, that is 3 multiplied by 2 minus 1 multiplied by 1, which is 5. For 3 by 3 matrices, cofactors of first row are C11 is equal to, we know C11 is M11, that minor 1 1, where first row and first column is deleted, we get A to 2, which is equal to the product of these two minus the product of these two. C12 is equal to, we know C12 is minus M12, as 1 plus 2 equals 3, which is odd, minor 1 2, where first row and second column is deleted, we get A to 1, which is equal to the product of these two minus the product of these two. C13 is equal to, we know C13 is M13, that minor 13, where first row and third column is deleted, we get submatrix this, which is equal to the product of these two minus the product of these two. Substituting the value of cofactors, we get this. Example. A is 3 by 3 matrix, then determinant A will be, substituting the value in this equation. A 1 1 is 1. A 2 2 is 2. A 3 3 is 1. A 2 3 is 3. A 3 2 is 0. A 1 2 is 0. A 2 1 is 0. A 3 3 is 1. A 2 3 is 3. A 3 1 is minus 1. A 1 3 is 1. A 2 1 is 0. A 3 2 is 0. A 2 2 is 2. A 3 1 is minus 1. We get this, which is equal to 4. Find the minors and cofactors of all the elements of this determinant. Solution. Minor of the element Aij is Mij. A11 is equal to 1. M11 is equal to minor of A11 is equal to 3. That is, since M11, first row and first column are deleted, we get 3. M12 is equal to minor of the element A12 is equal to 4. That is, first row and second column are deleted, we get 4. M21 is equal to minor of the element A21 is equal to minus 2. Here second row and first column are deleted, we get minus 2. M22 is equal to minor of the element A22 is equal to 1. Here, that is, second row and second column are deleted, we get 1. A11 is equal to minus 1 to the power 1 plus 1. XM11 is equal to minus 1 to the power 2 times 3 is equal to 3. A12 is equal to minus 1 to the 1 plus 2 times M12 is equal to minus 1 to the power 3 times 4 is equal to minus 4. A21 is equal to minus 1 to the power 2 plus 1 times M21 is equal to minus 1 to the power 3 times minus 2 is equal to 2. A22 is equal to minus 1 to the power 2 plus 2 times M22 is equal to minus 1 to the power 4 times 1 is equal to 1. Find the minors and cofactors of minus 4 and 9 in this determinant. Solution. Minor of minus 4. Here this minus 4 is here. That is second row, first column, M21. Deleting second row, first column, we get this determinant, which is equal to the product of A11 and A22 minus product of A12 and A21. Which is 2 times 9 minus 3x minus 8, which is 42. Cofactor of minus 4 is minus 1 to the power 1 plus 2 multiplied by 42, which is equal to minus 42. Minor of 9, 9 is here, that is third row, third column, deleting it, we get this determinant, M33, which is equal to the product of A11 and A22 minus product of A12 and A21. Which is minus 1 times 5 minus 2x minus 4, which is 3. Cofactor of 9 is minus 1, 3 plus 3 multiplied by 3 is equal to 3. Let's understand adjoint matrices. Adjoint matrices. We have seen a cofactor matrix C of a matrix A is the square matrix of the same order as A in which each element Aij is replaced by its cofactor Cij. Example: if A is this, then cofactor of A is. To calculate cofactor, we need to calculate corresponding minor. M11 is equal to minor of A11 is equal to 1. That is, since M11, first row and first column are deleted, we get 4. M12 is equal to minor of the element A12 is equal to 2. That is, first row and second column are deleted, we get minus 3. m to 1 is equal to minor of the element a to 1 is equal to minus 3. Here second row and first column are deleted. We get 2. m to 2 is equal to minor of the element a to 2 is equal to 4. Here, that is, second row and second column are deleted. We get 1. Substituting the corresponding value of minor m, we get a11 is equal to minus 1 to the power 1 plus 1 times m11 is equal to minus 1 to the power 2 times 4 is equal to 4. a12 is equal to minus 1 to the power 1 plus 2 times m12 is equal to minus 1 to the power 3 times minus 3 is equal to 3. a21 is equal to minus 1 to the power 2 plus 1 times m21 is equal to minus 1 to the power 3 times 2 is equal to minus 2. a22 is equal to minus 1 to the power 2 plus 2 times m22 is equal to minus 1 to the power 4 times 1 is equal to 1. The cofactor C of A is 4, 3, minus 2, 1. Let's understand adjoint matrix. Adjoint matrix of A, denoted by A, D, J, A. It is a transpose of its cofactor matrix. A, D, J, A is equal to C transpose. It can be shown that A times adjoint matrix A is equal to adjoint matrix A times A, which is equal to determinant AI, where I is unit or identity matrix. Example, this matrix A. Here, determinant A is 1, 4, minus 2, minus 3 is equal to 10. As we know, adjoint matrix A is equal to C transpose. We have calculated the cofactor above, which is 4, 3, minus 2 and 1, and transpose of it is interchanging row and column, which is this. A times adjoint A is equal to this, multiplied by this, which is this, that is equal to 10i, 10 times unit matrix. Adjoint matrix A times A is equal to this, multiplied by this, which is this, that is equal to 10i, 10 times unit matrix. Hence, A times adjoint matrix A is equal to adjoint matrix A times A, which is equal to determinant AI, where I is unit or identity matrix.
Using the adjoint matrix in matrix inversion. Matrix inversion में adjoint matrix का use होता है. We know A into A inverse is equal to A inverse into A is equal I, identity matrix, and A into adjoint matrix A is equal to adjoint matrix A into A is equal to determinant A into I identity matrix, then A inverse is equal to adjoint. Matrix are divided by determinant A. Example 1. Check A into A inverse is equal to A inverse into A is equal I, identity matrix, for the given matrix. Solution. We know A inverse is equal to adjoint matrix are divided by determinant A. Here, determinant A is product of diagonal 1 and 4 minus product of diagonal 2 and 3, which is 10.
Cofactor C is Cij is equal to minus 1 to the power I plus j into Mij. For C11, M11 is deleting first row and first column, we get 4, therefore C11 is minus 1 to the power 2 into 4, which is 4. For C12, M12 is this, deleting first row and second column, we get minus 3, and so C12 is minus 1 to the power 1 plus 2 equals 3 into minus 3 equal 3. For C21, M21 is this, deleting second row and first column, we get 2, and so C21 is minus 1 to the power 2 plus 1 equals 3 into 2 equal minus 2. For C22, M22 is this, deleting second row and second column, we get 1, and so C22 is minus 1 to the power 2 plus 2 equals 4 into 2 equal minus 2. We get C is equal to 4, 3, minus 2, 1. C transpose is interchanging row and column. This row 4, 3 is written as column 4, 3 and this row minus 2, 1 is written as column minus 2, 1. Substituting the values in A inverse is equal to adjoint matrix A divided by determinant A. We get this A inverse is equal to adjoint A divided by determinant A, that is 10. Therefore, A inverse is 1 by 10 times 4, that is 0.4, 1 by 10 times minus 2, that is minus 0.2, 1 by 10 times 3, that is 0.3, and 1 by 10 times 1, that is 0.1. To check this, A inverse is equal to this multiplied by this. 1 times 0.4 plus 2 times 0.3 is 1. 1 times minus 0.2 plus 2 times 0.1 is 0. Minus 3 times 0.4 plus 4 times 0.3 is 0. Muni's 3 times minus 0.2 plus 4 times 0.1 is 1. This is identity matrix I. Similarly, multiplying A inverse by A, we get 0.4 times 1 plus minus 0.2 times minus 3 is 1. 0.4 times 2 plus minus 0.2 times 4 is 0. 0.3 times 1 plus 0.1 times minus 3 is 0. 0.3 times 2 plus 0.1 times 4 is 1. This is identity matrix I. Therefore, A into A inverse is equal to A inverse into A is equal I, identity matrix. Example to check A inverse is equal to A inverse A is equal to I for the given matrix. Solution. The determinant of A is 3 times product of these two, that is minus 1 minus product of these, that is 0, minus 1 times product of these two, that is minus 2, minus product of these two, that is 0, plus 1 times product of these two, that is 4, minus product of these two, that is 1, which is equal to minus 2. The elements of the cofactor matrix are C1 1 is plus minus 1. C1 2 is minus 2. C1 3 is plus 3. C21 is minis minus 1. C2 2 is plus minus 4. C2 3 is minus 7. C3 1 is plus minus 1. C3 2 is minus 2. C3 3 is plus 5. Therefore, cofactor matrix is this. Adjoint A is equal to C transpose. We get C transpose by interchanging rows with column of C. That is, this row is interchanged with this column. This row is interchanged with this column. This row is interchanged with this column, and we get CT as this. Substituting the values in the formula for A inverse is equal to adjoint matrix divided by determinant A, we get this. Dividing each element by minus 2, we get this. The result can be checked using this. Note: the determinant of a matrix must not be 0 for the inverse to exist, as there will not be a solution. मतलब inverse matrix का determinant 0 नहीं हो सकता. Non-singular matrices have non-zero determinants. Singular matrices have zero determinants. मतलब singular matrices में determinant 0 होता है, और अगर determinant 0 नहीं हो तो वो singular matrix नहीं हो सकता. Now, let's understand more of matrix inversion in simple 2x2 case. Let matrix A be this, A inverse be this. Since we know A inverse is identity matrix, this. Multiplying A and A inverse. AW plus BY is equal to 1 equation 1. AX plus BZ is equal to 0 equation 2. CW plus DY is equal to 0 equation 3. CX plus DZ is equal to 1 equation 4. It can be shown determinant A is equal to AD, BC. From equation 1, y is equal to 1 minus AW whole divided by B. From equation 3, y is equal to minus CW whole divided by D. Therefore, 1 minus AW whole divided by B is equal to y is equal to minus CW whole divided by D. W is equal to D divided by dA minus BC is equal to D divided by determinant A. Similarly, from equation 2, Z is equal to minus A by B. From equation 4, Z is equal to 1 minus Cx whole divided by D. Equating 2 and 4. Minus Ax by B is equal to 1 minus Cx whole divided by D. X is equal to B divided by minus dA plus BC is equal to minus B by determinant A. From equation 1, W is equal to 1 minus By whole divided A. From equation 3, W is equal to minus dy by C. Equating, we get 1 minus By whole divided A is equal to minus dy by C. Y is equal to C divided by minus AD plus CB is equal to minus C by determinant A. Similarly, from equation 2, X is equal to minus BZ by A. From equation 4, X is equal to 1 minus DZ whole divided by C. Equating 2 and 4. Minus BZ by A is equal to 1 minus DZ whole divided by C. Z is equal to A divided by AD minus BC is equal to A by determinant A. So, for a 2 times 2 matrix, the inverse can be constructed in a simple fashion as A inverse is this. Substituting the value of W, X, Y, Z, we get this. Taking 1 by determinant A out as common, we get this, A inverse. Shortcut. Exchange elements of main diagonal. Change sign in elements of main diagonal. Divide resulting matrix by the determinant. Example. A is this. A inverse is equal to CT by determinant A. Determinant A is equal to 2 times 1 minus 3 times 4 is equal to minus 10. C transpose is equal to exchange elements of main diagonal and change sign in elements of main diagonal. Divide C transpose by the determinant A, that is minus 10, which is equal to this. Check inverse, A inverse A is equal to I. So multiplying A and A inverse we get unit matrix I.